Hello, good morning friends. Today we are going to see the unit number 3, that is spillways. Here we will see the important type of a spillway, that is a Ogi spillway, which is provided on the most of the dams, gravity dams you can say. It is an overflow section of a dam, but we have to see the profile should exactly match to the lower nappy of the flowing water. Otherwise there may be a cavitation problem and all these things. We will see one by one. So the Ogi spillway, this is a spillway which is Ogi spillway. It may be a gated or non-gated. Even if it is a non-gated, then only Ogi shape will be there, and a length of a spillway should be provided in such a way that it should be within the freeboard of a dam. So maximum water level should maintain the requirement of the freeboard of the dam. So this is the just components, that is a spillway, that is the Ogi shape, then gates, and here at the downstream side of each spillway, it is the requirement that we must provide a energy dissipation arrangement, just like a stealing basin, end wear, and all these things. This we will see one by one. Here practical profile of a spillway. When the profile for the crest of the Ogi spillway is plotted over the triangular profile, the section of a gravity dam, that is which is non-overflow section, that is found that it should match to the non-overflow section in such a way that curve or the lower nappy section should be fitted in such a way that the overflow section and non-overflow section should match. Only there will be the rounding up of the top portion at the normal pool level. Here you can see this figure. The darkened one is our regular non-overflow section, and here we are seeing the shape of the lower nappy. So that curve is to be shifted in such a way that we can have the optimum shape of a dam, so the excess material should not go. Here, however, it is the extra concrete can be saved by shifting the curve of the nappy to the backward direction until this curve tangential to the downstream face. Means only top portion will be in a curve, that is a parabolic shape, then circular shape, and again another small circular shape, and that curve should be tangential to the downstream slope of the overflow section. This is the shape. There sometimes there may be overhang, but in our study we are neglecting it and matching the curve shape in such a way that perfect rounded shape should be formed with the help of a parabola and the circular section. We will see one by one. So this is the offset. This is we are not considering in our problem. We have to do one exercise on that, and also it is included in our term 1. Height of a spillway crest above the stream bed. The height of the weir is 1.33 HD. We have to see whether that HD is equal to, means the effect of velocity approach is to be considered or not. That can be verified by HD equal to SD. SD is the design head. This is the energy head. If P by HD is equal greater than 1.333, there will not, or it will not be necessary to consider the velocity of approach. This is the perfect Ogi shape, having the vertical top portion of a dam is having upstream face as a vertical. Then we will have two small curve, that is R1 radius and R2 radius, and there will be a parabolic shape which will be again tangential to the downstream slope of a spillway. So downstream shape of the non-overflow section. And this parabolic equation will be x to the power 1.85 equal to 2 hd raised to the power 0.85 into y. The axis of that parabola is at a distance a, which is equal to 0.282 of a hd. All the parameters are based on the hd, so hd is to be calculated properly. The origin will be at the distance 0.282 of hd from the vertical face, from which the parabola will start, and towards the upstream side we will have some circular curve. R1 will be equal to 0.5 of hd, and R2, that distance again b is to be calculated, that b is equal to 0.175 hd for a length of that R1. Then R1 and R2 means R2 will be between the vertical intersection and the R1 portion, that radius will be 0.2 of the hd. Various parameters. First we have to consider the design flood. The formula for the flow over Ogi spillway is Q is equal to CD LE HE to the power 3 by 2. where the for OG section CD that constant of discharge is 2.2. L is the effective depth depending upon the number of gates provided, and where the N is the number of gates. Kp and Ka are the coefficients for contraction due to the abutment and pier, and then we have to find out the Le. For every problem, first we will have the number of gates opening. We will assume L equal to Le and calculate the He. Then He from whether the velocity of approach is to be considered or not, that is to be considered, and then we will go for finding the HD. Finally, SD will be considered for calculation of all the means the parabola, circular curve, and all these things. So this is just a simple. We have to take the from the origin, from where the parabolic curve is starting. We have to take the distance x. X we can consider 1 meter, half meter, 1.5 meter, and like that. And then we have to finding the y is equal to some function. So this will be y is equal to x to the 1.85 divided by 2he raised to the power 0.85. This will be the equation. Just we will go in the filling the values, and we will get the values of where from the various points obtained from this table. We will draw a fine parabolic curve. Okay. Radius at now where the downstream slope of a dam meets to the horizontal floor of a stilling basin, where the curve is to be provided. That radius is P by 4, where the P is total height of water, means up to the maximum water level, H plus He, including water from the water level from the foundation up to the HFL, that will be H plus He. Substituting the values, all the parameters is to be calculated, and we will have this shape. This is the toe curve which is having the radius r is equal to P by 4. This is the your downstream slope of a non-overflow section. Then the parabolic section which was having the parabolic equation, then R1 and R2, and this is your complete OG spillway. We will see one problem so that your ideas will be more clear. Let us see design of a spillway, design an OG spillway for a concrete gravity dam for a following data. What is given? The river bed level, RL of the spillway crestment, you have given the height, and the discharge will be there. Slope, what is the downstream slope, then design discharge, and the length of the spillway, that is the number of gates and the opening size of the gate, and the thickness of the each pier. This is required, these gate details are required to find out the effective length of a spillway. Let us see the problem. Q is equal to C LE, He raised to the power 3 by 2. Le equal to L minus, this is the formula, L equal to Le. Our first step will be, we are going to assume Le equal to L, means the number of gates into opening of each gate. So this will be your clear length. From that you are going to find out the He, and with the help of He, putting that He height into that, you will find the HD. Let us see. Q is equal to C LE He to the power 3 by 2. First finding L equal to Le, then we will find Le is equal to something, then put the value of Le, having the discharge you will find He. So He will be 19.24 meters. Now He 19.5 meter, H equal to, again we will find the H upon HD equal to greater than 1.5, H upon HD is equal to 5.12, so it is greater than 1.33, the velocity approach can be neglected. Again we have to see that whether the discharge coefficient, that 2.2 we have considered, which is constant or not. This H plus HD upon SD, if its value is greater than 1.7, then we did not have to consider the effect of change in the coefficient of discharge also. See, now Le is found out. Q is equal to this, putting into the equation you will find the He. He equal to, by getting He you will get the x coordinate formula, that parabolic formula, x to the power 1.85 equal to 2 HD raised to the power 0.85 y. So in terms of y, equation will be there, so that we can take the value of x and find the value of y. So up to what point it is to be calculated? dy by dx, means it is a match to the, so the dy by dx is equal to that whatever the slope given, then these two lines will be tangential to each other. So this is the slope given is 1.75. So up to how much length we have to find out. Just we will see that x coordinate is to be found out, then y coordinate. So x come to be 33.6, x max, where there is a tangent point. This is the parabola from origin, so 33.6, and the y coordinate will be 24 meter. Let us see. This is your y equation, upstream profile. Then this was x. This curve will extend up to this one. Okay. X coordinate as well, then y coordinate we will just put, and this is the final shape of your bogie spillway. Thank you very much, friend.